Kyle knows the deal. Kyle knows I'm going to forget. All right. For those of you that are joining us with the show already in progress, here's what you've missed. What you missed so far is that my kid just paid a ridiculous amount of money at the University of West Florida to buy books from the bookstore. And when I asked him how come he didn't send them to me so that I could try to outsource them a little cheaper, he said he didn't know you could. And we were discussing whether or not you've bought the college algebra book. What I said is that this is the book that you need. And generally, for those of you that don't know, there's a lot of places you can buy textbooks. The bookstore on campus is one place, but like I explained to him, if you've ever been to a fancy hotel that's got that convenience store, the convenience store in the fancy hotel, while they may sell bottles of water, it won't be for the same price you can buy that bottle of water at Walmart. And so, even with Vital Source, you can rent it for $45. And that's a pretty good. Vital Source is just an online consortium of books that you can get. And so kind of the thing is, you find the book that you need, you see the cover, and then you jump over to Amazon and you see if they sell it. And the thing that, I noticed was he bought a art history book for an art class he's got to take. The art history book was $170. I typed it into Amazon and I could have rented it for $18. And so, you just realize that, he being a freshman, he doesn't know the difference. He doesn't know what the hell you're supposed to do. He just assumes you're supposed to go to the bookstore and buy everything. For those of you that don't know, this is what you can do. Go to Amazon, type in the title, look for the cover that matches what you're supposed to have, and then try to find it from an independent source. For those of you that don't have the book, if you haven't gotten the book yet, if you haven't gotten the book yet, in section 1.1, you have to do 77 through you got to do 77 through 103. And so what I said was, for those of you that don't have the book, I will leave this up for you as a means of you having the problems if you need them. So if you want to take a picture of that, take a picture, and then you can try to work through them. All right, so 77 through 103, so there's 77 through 80. And then there's 81 through 84. You can take a picture of that if you want to. There's 85 through 94. And 95 through 100. One 101 and 102. And then 103. Additionally, today we're going to do section 102 or section 1.2, and that's 1 through 63. That's 1 through 63, so there's 1 through 16. 17 through 30. (31 through 37). (38 through 43). And I apologize. I don't know that I can make this be any much better than it is. Let me see. That picture is just not very good. I wouldn't worry about that one. There's a lot of other crap to worry about. I wouldn't worry about that. All right. 47 through 52. All right. All right. So you're doing 1 through 63, and then 71 through 81. We'll just say 71 through 78. All right. Any questions about the homework? Anybody who's here, any questions? Again, go ahead.
It's not about homework. It's about DOQ. Is that tomorrow or?
No. Don'ts and questions will start next week.
Okay. I just need to know. Thank you.
Yeah. No, you're good. Appreciate you. All right. So in section 1.1, you're kind of tasked with these three things. You're tasked with essentially the Pythagorean theorem. Right? Then the Pythagorean theorem would lead you directly into the distance formula. And then kind of a subsidiary to the distance formula becomes the midpoint formula. And how do we handle the midpoint? All right. So I'm going to spend a little bit of time running through some examples of Pythagorean theorem. And just to first of all remind you what the Pythagorean theorem says. So as we talk about the Pythagorean theorem says a squared plus b squared is equal to c squared. All right, that's what the Pythagorean theorem says. And it works with right triangles. So if I have a right triangle where it says, you know, hey, we know that A is, for example, 4 and B is, for example, 7, it would ask me what is C. Okay. Now, as a general rule, C is always the longest side of the triangle, and we call that side the hypotenuse. So in this case, C is the opposite side of the right angle. All right. How you label A and B are relatively arbitrary at that point. But at the end of the day, all you're using is A is 4, B is 7, and you're solving. So 4 squared plus 7 squared equals C squared. So 4 squared is 16. 7 squared is 49. And that's equal to c squared. So that becomes 5065. Equals c squared. And so then c becomes the square root of 65. Okay. All right. Now, keep in mind that you might have to break down the square root of 65. 65 is 5 times 13. Give me a second, please. I'm trying to remember this dude's name. I think his name is John. All right. If there's a perfect square in there, you want to take it out. Right? If there's a perfect square in there, I can't find the guy's number. His name is John, though, I think. You want to take out a perfect square, but there isn't one in this case, so we just leave it the way it is. Okay. Any questions for anyone who's here on that? Everybody good?
I am.
All right. Now, where that gets difficult, if I'm being honest, like that in itself shouldn't be that dang on hard. Give me 1 second.
AV Services, this is John.
Hey, John, how you doing?
Doing pretty well about yourself.
Hey, man, I am in the middle of a live stream. You are live and in person, baby. So, you better watch what you say because they're recording it and the students are listening to you, all right?
Very well then.
I say that so I can try to get my way. You know what I'm saying?
Oh, of course, absolutely.
Hey, listen, this little pen in here that works on this little symposium, it only records about a third, maybe a half of the strokes that I make. Is it the pen, you think? Is it the symposium, or is it this computer?
Yes. We can bring another pen over and try it.
Can we do that?
Yeah, absolutely.
Appreciate you, John.
No problem.
You're the best. Take care. Bye. All right, guys. Sorry about that. I don't know if y'all can tell that when I write, the pen doesn't always write. Like, it doesn't. Alicia, could you tell that when I write, the pen doesn't always write? All right. Have you noticed, Alicia, I've done much better about not cussing when it happens. See? This is the new spiritual me. All right. So now, where does this start getting complicated? Well, it can get complicated because sometimes all right. And I know why it does, and I don't think it should, but it does. It gets complicated sometimes because they'll tell us that A is like the square root of 5. They won't tell us B, and then C is like the square root of 23. All right. And this, for whatever reason, tends to kind of screw a student's head, right? Like, it's kind of like, whoa, what the heck? Why you got to go put square roots on that stuff? And the answer is it doesn't matter, right? Like, if it's a squared plus b squared equals c squared, you're still just going to plug in whatever they give you. All right. And so this is square root of 5 squared is 5. Square root of 23 squared is 23. And now you're going to subtract 5. You're solving for b. And you're going to get b squared equals 18. And then we're going to take the square root of both sides. And we're going to get b equals 18 is 9 times 2. Which is 3 times the square root of 2. All right. We good? Now, good?
Can you go back 1 second? I didn't get the right of that last bit.
Mm-hmm. Hey, Corey, do you got a suggestion for a donut place?
I don't go to many donut places. I have been to Dunkin' Donuts before, and they're not bad. But I can't. That's only my experience. I haven't been to other donut places. Be like it's Krispy Kreme.
Yeah. So my vote would be Krispy Kreme, but I'm gonna be honest. Like Corey, I'm gonna be real honest right now. Okay, and that is if I drove my fat butt to Krispy Kreme to pick up donuts for the class, I don't think any donuts are gonna make it inside. Like I do believe I would eat all of them on the way over here. Like
That's
let me just keep it real with you, Alicia. Let me just be honest about what's going to happen. Like, I know what will happen, especially if the hot and ready sign is on. Oh, forget about it. They're not making it over here. It's just not a chance. Like, you're going to show up. I'm going to have glaze on my face. You're going to be like, whoa, what the heck? But I'm going to be like, you know what? Don't judge. All right. Any questions on this? We're not doing Dunkin' Donuts for the record. Like, Alicia, I got a coupon. And that makes them buy 6, get 6 free, and I still won't go there.
I'll take it.
Oh, dude, I'll give it to you. Just show up. I mean, are you coming to Donuts and Questions?
Sure.
All right, hold on. I got my man John right here. Y'all say hi to John. They ain't say hi to your ass.
I ain't worried about it.
You see what I'm saying?
Yeah.
This is better than, you see what I mean?
Yeah.
Now this is doing well, maybe not so much. Like, what do you think it is?
I really don't know. I know these damn things have been giving us a lot of problem lately.
I mean, you know. But Alicia will tell you that I've been on my best behavior today.
I find that hard to believe anytime.
So this is not terrible. This is better than the other one was.
Okay.
You see what I'm saying? No, that's pretty good right there.
Okay.
Yeah, you can take this one back.
Yeah, we can get rid of that sucker.
All right.
Yeah, I'm just, like I said, if it keeps acting up, let us know. We don't have anything else in stock to replace it with right now,
Oh, then we need it.
right?
Yeah. I mean, hey, look.
Yeah.
You know.
I would like to find a better solution than these things. These things have been a pain in the ass. There has to be something out there.
Hold on for a minute. I just got to go. Hey, Alicia, his name is John. He's the one who said it was a pain in the ass, not me. I have turned over a new leaf. I have a new spiritual awakening, and I would have said it has been a pain in the patootie. That's what I would have said.
Throwing everybody under the bus.
Just throwing you right under the bus, John.
You know, put it in reverse and back up.
They sure will. Love you, John. Take care now. That was my boy John right there. He comes through in the clutch, man. That dude's like Tom Brady. Now, how do we use Pythagorean theorem to handle the distance, right? How do we use Pythagorean theorem to handle the distance? Now we're going to move up. Uh-oh. My pen's working too darn good. Look at there. How do we use Pythagorean theorem to handle the distance? Well, it starts with a distance formula. Now, I've long questioned, how do I handle this, right? How do I handle the distance formula? I'm just going to tell you what it is. D equals, see, my boy John done left, now it's starting to act up again. X2 minus X1 squared plus Y2 minus Y1 squared. Now, I think in an ideal world, you would commit that to memory, right? Like if this is your memory and it's totally full, you would take your mom's birthday and replace it with the distance formula, right? Like if your memory bank is full, just get rid of your mom's birthday, use the distance formula instead. And then when she calls you all pissed off, just assume that was her birthday, okay? And then be like, Mom, I can't remember your birthday and the distance formula, and I'm choosing the distance formula. I think she'll be okay with that. So I want you to memorize it, but I'm having a hard time justifying the reasoning. Couple thoughts. Number one, for those of you going the college algebra statistics route, which is, basically trying to get your 6 hours of math credit and you're done. We don't use the distance formula in statistics ever. And so then I'm thinking, like, where in the rest of your life are you ever going to use it? And the answer is, I don't think you'll ever be at Publix going, I'm at the milk. I want to get to the watermelons. So let me quickly get out the hypotenuse. Like, I just don't feel like that's ever going to happen. On the test, you get to use your notes because it's online, so I'm going to allow you to use your notes. So just write it down and have it somewhere where you can easily access it. Okay? And so the distance formula is D equals X2 minus X1 squared plus Y2 minus Y1 squared. If your goal is to go into engineering and you got to, or being a doctor or something where you got to take more math classes, then totally might want to make sure you remember that because we do use it some of those upper level courses. But if you just got one more math class and then, then you're doing the happy dance, then I guess just write it down and save it somewhere and then never use it again probably. But I can ask you for the distance between, like, say the point 2, 4 and say 5, 12, right? So what am I asking you to do? What I'm saying to you is you have this point here, which we'll say is 2, 4. You have this point here, which we'll say is 5, 12. And I'm asking you for this distance. Okay. And essentially what the distance formula does is it turns this into a triangle where this becomes the hypotenuse and this becomes side A and this becomes side B. Okay. Most people just choose to use the formula and don't worry about it. Although they do have a hard time if they don't have the formula in front of them because they don't know how to get to the formula. But it's essentially a triangle where you just form a triangle. It doesn't matter which direction you do it. You can do it this way. If you were so inclined, you could do it this way. It's the same. It would be the same thing. Okay. But essentially you're doing 5 minus 2 plus 12 minus 4 all right, so 5 minus 2 squared is 9. 12 minus 4 is 8, squared is 64. And so this distance then becomes the square root of 73. Right. Hey, Brooke.
Hello. Yes, sir. Can you hear me now? Okay.
Yeah, I can hear you, baby. How you doing? You good?
Yes, sir. I'm good.
You got all this figured out so far?
Yep, I think so.
Okay. Hey, Brooke, do you know, have you ever been to the University of Florida? Have you ever driven there?
Yeah, I've been there for a soccer tournament before.
You went there for a soccer tournament?
Mhm.
Have you ever been to Tallahassee?
Actually, I don't think so.
No, okay. You do realize Tallahassee is a little north and a little west of Gainesville.
Yes.
About an hour and a half, 2 hours.
Mhm. Yeah.
Well, tomorrow, part of the reason why we're not having donuts and questions tomorrow is I'm going to West Florida, which is in Pensacola, to go see my son play football. They're having a exhibition game tomorrow, so I'm going to drive up and go watch him play.
That's cool. I used to have family in Pensacola.
So you've driven to Pensacola before?
That was not fun. It was far.
That's a long way, isn't it?
Yeah.
So here's what's crazy, right? What's crazy is from here, you kind of got to take, you kind of got to take 27 or 429. You got to get to the Florida Turnpike, right?
Mhm.
And then from the Florida Turnpike, you got to get to 75, right?
Yeah.
So I always felt like it was like 3 stages, right? It was like get to 75 is stage 1. Then stage 2 is get from 75 up to, kind of where I-10 is. That's like stage 2. And then when you get on I-10, that's like stage 3, because when you get on I-10, you're basically not there, but you're on the road you got to be to get there. And so it makes you feel better a little bit. You know what I'm saying?
Yeah.
Except that you have to be on I-10 for like an hour and a half before you even get halfway.
Mhm.
Right?
Yeah.
And so the last time I drove was a couple weeks ago. I kind of just like wanted to know, like, where's the halfway point, right? Because there's something mental about that halfway point. Does that make sense?
Yeah.
Like, okay, I'm halfway there. And so, like, I actually devoted a great deal of energy because I was driving by myself to thinking about where exactly the halfway point is. And I devoted energy to that and exactly where does the time change from Eastern time to Central time, because I always want to know where that is. And I always forget when I get on the road again where the damn thing is. But I know it's going over a bridge somewhere. But the midpoint, when we talk about midpoint, midpoint is essentially that halfway point. Does that make sense? That's what I mean by that's what I mean by midpoint. Midpoint would be the point here where the distance from here to here is the same as the distance from here to here. That's what I mean by midpoint. Now, when I say midpoint, you can think of midpoint as the average. Okay? Now, it occurs to me that there's some people who don't know how to find the average of two things. Like, what's in the middle of two things? Like, how do you find the average? Like, what's in the middle between 5 and 10? I asked my daughter that yesterday. She said 7. I said, honey, 7 is only 2 away from 5, and it's 3 away from 10. So it's not 7. And she goes, okay, fine, 8. I'm like, well, 8 is only 2 away from 10, and it's 3 away from 5. So it's not 8 either. And then she goes, okay, it's somewhere in between 7 and 8. And I'm like, okay, I agree. And what would that be? And she's like, I don't know. 7.1, 7.2, 7 point something. She's in 8th grade. You got to give her a little bit of grace. How do you find the middle point between 5 and 10? You add them together,
And then divide.
and then you divide by 2. And you would say that the middle point between 5 and 10 is 7.5. You add them together and you divide by 2. So when you think of the midpoint, what you should think of is add together and then divide by 2. So the formula, which is x1 plus x2 over 2 and y1 plus y2 over 2, is simply the adding of the 2 points together and dividing by 2. So if I said to you, we have the point 2, 4, and 5, 12, and I want to find the midpoint, essentially all I do, and I just do it like this, although you could use the formula just as easy, I simply just write them up vertically. I add them together. 5 and 2 is 7. 12 and 4 is 16. And then I divide by 2. So the midpoint becomes 7/2 and 8. If you wanted to use the formula, you would say it's 2 plus 5 divided by 2 and 4 plus 12 divided by 2. Okay. All right. Any questions on that? Questions, comments, concerns?
No questions. Just can you show the last screen real quick?
This one?
Yeah, I just need to write it. I didn't need to write the last few notes. I can just screenshot it. Thank you.
All right, you good?
Yeah.
All right. Let me talk a little bit about domain and range, because this is a big concept that we go over. This is section 1-2, by the way. This is section 1-2, by the way. All right, domain and range. All right. We go over domain and range a lot in this course. It's a function of dang near every section we cover. So let's look at domain and range. Just want to remind you, domain is the x values and range is the y values. Okay. Alicia, it's one of those. Alicia, are you good? Okay. Alicia, it's one of those deals where, we assume that people know certain things, and then sometimes we find out later that they don't. Does that make sense? Alicia, is your dad a college professor? Alicia, would it seem obvious to you that if he were a college professor, you would ask him about any textbooks you had to buy before you went out and spent like $500 of his money? See, I assumed that he would, and then when he didn't, it occurred to me that he didn't know he was supposed to. Oh, no. Honey, he's a football player. He's not going to an art school. He just has to take art appreciation. No, he's actually on scholarship, so it's not that bad. That's why I'm not terribly mad at him, because, he did get quite a bit of money in scholarships, but so it hasn't really cost me all that much. Yeah, no, it's not that. I asked him why he was taking art appreciation, and he said because he thought that was better than music appreciation. And I was like, what, those are your two options? Like PE is not an option? And he was like, no, Dad, they make you take either art appreciation or music appreciation your first semester. And I was like, what kind of damn school is that? Good thing I didn't go there, because I definitely don't see no appreciation in art or music. But I do see math appreciation. I would have taken that class. But when you assume that people know things and then they don't, it's a really kind of crappy situation, right? Because I assumed you know it, and then you don't know it. So then you feel bad because you don't know it because I assumed you did. And then you're like, well, maybe I was supposed to know it. So as a general rule, as we go through this course, I'm going to assume that you don't remember everything. Okay, Alicia? Is that okay? I'm not trying to insult you. I just think it's better if I assume you don't know than it is if I assume you do. Brooke, does that make sense?
Yes, I agree with that, because people forget little things sometimes.
100%, especially if you haven't done it in a little minute or two.
Yeah.
And I do it every day, and I've been doing it every day for 6 weeks or so for sure. And so, I don't tend to forget it, but I also do it all the time. So let us just go back and remind everybody that domain is X, range is Y. And that when I look at a graph, see, this is me being tested, but I'm not going to fall for it. When I look at a graph, and I'm asked, what is the domain? Or I'm asked, what is the range? I want to remind you that we read the domain from left to right, and that we read the range from bottom to top. Now, domain are X values. So when we talk about the X values, When we talk about the x values, we're talking about all, there we go. Come on, you can do it. Come on, there we go. We're talking about all of those values. As a reminder, infinity is to the far right. Negative infinity is to the far left. When we talk about the range, we're talking about all of these values. Okay? I remind you that infinity is at the top and negative infinity is at the bottom. And so that while this infinity and this infinity may look the same, they are functionally totally different. That is two totally different that's two totally different places. All right. Laylee?
Yes, I'm here.
Can you hear me?
Yes.
Hey, Laylee, who do you think has the best chicken wings in Winter Haven?
That's a hard question.
You don't eat chicken wings, do you?
I do a bit. What's your favorite?
So I don't think it's even very close. I think Florentino's is by far the best.
I never ate from there.
Oh my gosh, Laylee. It is like if you get the monster wings they have, like you feel like you eating on a turkey leg. I ain't even gonna lie to you. Hey Corey, have you experienced the Florentino's chicken wings?
No, I have not, sir.
So here's the thing, Corey. I went to go work out, and a lot of times when I go work out, I started this new exercise thing. I've been doing pretty good since about March. I really haven't lost any weight, but I've been doing pretty good. I've been going anyway. I guess it's just proof, Corey, you can't out exercise a bad diet. But like I'll go to the workout at like 5:30, and then I'll call a restaurant to get a to-go order for like 6:45.
Mm-hmm.
You know what I'm saying?
Mm-hmm.
Like then I can just leave the workout and go pick up my dinner. And so I called Florentino's, and it's right there near where I work out. It's like a 3-minute drive from where I work out. And so I got over there, and then I said, hey, I'm here to pick up my to-go order. Lady's like, what's your name? I was like, Steve. And she was like, we don't have a Steve here. And I was like, no, I called it in. And she's like, oh, let me go double check. And she went and double checked. And she came back, no, we don't have a Steve. And I'm like, what the hell? I know I called it in. And then she's like, what number did you call? And so I looked at it, and I told the lady the number, and she goes, oh, that's the one in Dundee. Lately, I was so blowed. I'm not even going to lie to you, right? Like, I just felt like I got kicked in the gut and somebody told me that Santa Claus didn't exist all at one time.
He doesn't?
I've done that before.
Oh, my bad, Corey. Yeah, no, it's been your parents the whole time.
Mm.
Hey, by the way, if you're watching this with your little brother, mute it. Because they might find out that Santa Claus doesn't exist. My bad. Parents, if you're listening, call Lakeland. And so, yeah, no, I was so upset. But, you know, the bottom line is this. Florentino's exist in two places. There's one in Winter Haven. There's one in Dundee. And if you go to one, you ain't at the other one. Found that out the hard way. And that's kind of what you're seeing here. This is Winter Haven. This is Dundee. Like, yeah, same place, same restaurant, same food, different locations. Okay?
Mm-hmm.
And so when I read this, if I say to you that this point is -2, 0, and I want to know what the domain is, I'm looking on the x-axis. I'm looking at the x values. So in this case, I'm looking at the x value. I'm looking at the -2. And I say that this domain is from -2, come on, do it, from -2 to infinity. Because it's going to the right. It's going to the right. That is infinity. It's going to the right. Now, if I ask you for the range, which is the y value, means we got to look at the y value here. The y value starts at 0. The y value starts at 0, and then it's going which direction? It's leaving 0. Is it going up or down? It's going down. So the y value starts at 0 and goes down. So that's from 0, in this case, -infinity. Okay? Because this arrow here is going to -infinity down here. It's going down. Now, people will look at it and go, that damn thing ain't going down. It's going to the right. Yeah, but the general direction is right and down. All right. It's going right and down. All righty.
Mhm.
All right. Any questions on that?
No.
Kyle, you good? Brooke, you good? Layla, you good?
So where you said right and down. Oh, can you hear me? Sorry, I don't know.
Yeah, I can hear you. Go ahead.
Okay, so when it's going right and down, is it in the way of the arrow?
Yes.
Okay.
Yeah, it's in the way of the arrow, and it's also in the way that it came before it. Like all of this line is heading towards the bottom.
Okay.
See, if it went this way, lately, then we would say that the arrow is going up and to the right. We'd say it's going up because this is the bottom point and the arrow is above it. Notice that this is the top point and the arrow is below it.
Yes.
So therefore, we say it's going down. Okay. Everybody good? All right, I'm going to leave you with that. So please go try section 1.1 and 1.2. If you have any problems, you have my email address. You know how to get a hold of me. Please feel free to send me a message and get a hold of me, okay? Any questions? All right, those are questions next week. Not this Friday, but next Friday, okay? We're out of time for today. We'll try the very next time. Until then, take care of yourself and each other. Y'all be blessed.
You too.